As a robotics software developer, your job is to solve a problem and make your work reusable. Instead of calling people and telling them how this works and how to run this, you solve that problem by documentation and telling about the dependencies. Dependencies are very important to understand because there are a lot of jargons inside of it. First, language specific, C++, Python dependencies, package XML, ROS2 and a lot of things. We will focus on solving dependency problem of specific projects with different use cases. But the main problem is always there. The package is not working. The efficient way of finding out what dependencies to install in one package. Let's get started. Turtlebot 3, a very popular and powerful package to learn ROS2. They have great simulations. We are going to utilize this package to understand the dependency problem. Let's first clone it. We are going to get this URL, create a ROS2 workspace directory and source directory inside of it. We are going to clone inside of the source directory. While it's downloading, let's take a look into the repository. There are a lot of packages inside of it. Turtlebot 3 Cartographer, Navigation 2. These are ROS2 packages with package XML, CMake list, C++ based packages. In this video, we are going to explore package XML a lot. Why this is like this and what is written inside of it and why it is very important to understand. Once it is cloned, we are going to go into the root directory of the workspace and perform calc build. And while we are performing calc build, we are going to look at some errors, and these errors tell us that in the CMake list of Turtlebot node. Let's try to debug this and look at it from which file this error came. So I'll pin this and go into Turtlebot 3 node, which is this one. Then in the CMake list 20, there is a command known as find package. It says line number 20, find package dynamixel SDK. This is causing error because it is unable to find the specified package. So what we actually do is to solve this problem by simply getting this name and installing it manually. Sudo apt get install ROS humble, as we are working on it, then dynamixel SDK. It searches the apt manager and it finds out that there is a package and it starts to install this specific package and it completes it successfully. So the error should now go away, right? Let's now build the package again, calc build. Understand that apt installs the binaries, and this is one very important concept. This does not make sense, later it will be, but it just installed the binaries, not the code of it into your workspace. Now once we tried building again, it said there is another error. In the same CMake list, you can observe in the line number 31, there is a dependency of Turtlebot 3 messages. So let's solve that one as well. This time ROS humble Turtlebot 3 messages. You have to just observe this whole process because I want to give a specific idea of what are the problems that people face and they say this is not working and how to solve them. Currently the second dependency that was giving an error is done. Let's perform calc build. So now it should work, right? You have to focus on this word, it should work. Performing calc build is not actually making things work. It is just compiling things. Once it is done, we are going to try to run some package out of it. So first we need to source the workspace and ROS2 launch Turtlebot 3. Let's go with navigation. And what are the available navigation launch files we have is navigation 2. I think it will ask about model of Turtlebot 3. Yes, it's going to ask you about model of Turtlebot 3. So I'll give just burger and now run the launch file again. It again said one of the packages missing. So this is a problem that we keep on installing packages and now another error of dependency issue, a package required to run thing has come up and we have to keep on installing things. Is that the proper way? Installing dependencies step by step, one by one is going to take a lot of time. There are packages that have dependencies of around hundreds. So in that scenario, there should be a proper formal way of installing with one command and all dependencies, specifically in an order. So there is no conflict. In that perspective, great people have done a lot of work. We can mention all of the package once in the package XML, and that tells us what are the dependencies that we need to install. So one command can install all dependencies of all ROS2 packages in the whole workspace. That's very powerful and easy to make the code work on different systems. Also for language specific like Python, we have requirements.txt, which involves all the pip related packages that we need to install. So these are the categories that we have to understand. Let's work on the package XML, and later on we will look into Python. Instead of writing one by one dependencies, let's go into our workspace, write a command for initializing rosdep versus sudo rosdep init to initialize rosdep. Currently I have already initialized it. Let's update rosdep. Let's try to install all dependencies of all the packages inside of our workspace. rosdep install, simple as it is, -y to automatically say yes to all of the requests of the packages to be installed. The path that you are going to take is source, everything inside of source. And also one very important parameter, ignore source. Now this source is a directory inside of source and installing all rosdeps inside of it. This ignore source is not to duplicate the packages as of binaries and also in the workspace, which might be confusing for you, but it will make sense. Let's first press enter and understand what is going to now happen. So first it brought up a package named as nav to bring up that we saw an error of, and it started to install it. After some time, you will observe a lot of dependencies will be installed. For example, ROS humble dynamics LSTK, then humble rwiz2, then this one, and the list goes on. Now, the important thing is everything is going to be automatically installed. We don't have to do things. Let's understand where these dependencies are actually written. So we were having errors here, right, in turtlebot 3 node. The file that mentions what dependencies we need that are all gathered at one single place in a list are in package XML. For example, when we were running the colcon build command in the start, the first error we got was of the dynamics LSTK, which is written here. So the thing is, all the dependencies, when you are building your software, you mention those dependencies here in the package XML. So whenever anyone runs rosdep, all of these dependencies are automatically installed. Then we don't have any error. As we were building, this was causing one error and this was also causing one error. So all of these are going to be automatically installed and things are going to easily run to whoever is using your project. Next thing to understand the scale of it, all these packages have package XML, and in package XML they all have dependencies, so all are going to be installed. If we take a look here, a lot of dependencies are now automatically installed in them. After installing all of these, perform colcon build now, source the workspace, and then ROS2 launch turtlebot 3 navigation and navigation launch file. We again have to provide turtlebot 3 model. It's going to be burger. Let's launch it. This time we can observe a lot of output is generated and a common problem of not having a transform for the ODOM because the simulation is not running or an actual robot, but you will not find any problem with the package not found or dependency is not there because turtlebot 3 is very well created by a very renowned company and they have documented everything for their dependencies and how to install and a lot of tutorials as well. So this is very important when you are building a package that should be reusable and it should have good package XML file with all the dependencies required. As a developer, you need to make difference between the dependency types. There are already built binary package dependencies that we install through sudo apt. Now there are dependencies which are language specific or pip packages that we do with pip install this or requirements.txt. Now there is one more aspect. There are some libraries that you need to build from scratch for your work, and also in that there is a subcategory that you want specific version of a specific repository or in GitHub to download and build for your project. Now for that specifically package XML don't work. You need to use another tool which is VCS version control tool, which is going to download the required repository into your workspace and you can build them. So let's take a look into this amazing thing which can automate a lot of stuff for your dependency related stuff. In this Turtlebot 3 repository, you see a lot of packages, and then there is one very important file that is turtlebot3.repos. There is ci.repo as well, but we will not explore it. Let's open this .repos file. What does it do? So there are rosdeps already there, but this .repos is actually about cloning these GitHub repositories with this specific version. For example, if you remember, when we tried to perform colcon build, DynamXL SDK was a dependency that was missing. So what this actually does, it clones the repository into your workspace and then you can build it. The previous way that we did was to use rosdep to install the apt compiled binary, but if you want to build it from source, it is going to go to this repository, and onto this repository the main branch of it is going to be cloned. That's how it is going to be working. So let's make sense out of it, why it is different from the rosdep installation and this VCS installation. If I just go into an older version of Humble branch and I open up the .repos file and check here, you will observe that they have provided the same link, but here technically they should have used the version of Humble, not the main branch, because in DynamXL there is a Humble branch that is specific for Humble development. So cloning for Turtlebot 3 Humble should be DynamXL SDK Humble branch and then compiling it. But let's perform the installation. Now let's take an example here. I go into the source and I found out that there is Turtlebot 3 and then there is this repos file. Let's move back to our workspace, and here I'm going to say VCS, import into the source, and the file you are going to search about is source turtlebot 3.repos. This is going to now download these repositories that are mentioned inside of these turtlebot 3.repos into my workspace. Let's verify. First of all, it cloned Turtlebot 3. We already had it, so it says that destination path already exists. Other than that, Turtlebot 3 messages, which is this one, it is there. Then Turtlebot 3 simulation, which is mentioned, Turtlebot 3 simulation and DynamXL SDK. All of these are now cloned. We can also visualize them. They might be in the utils. Yes, these are the things that are now installed and their repositories are cloned. So this is again a very important tool if you have a dependency of other repositories with a specific branch. When you are working with ROS2, you will observe colcon build. Previously it was cat can make. These are build systems and building tools. Now in most of the cases for a robot, you have sensors, but to compile a sensor package that is processing the sensor, there is a library specifically that you need in some of the nodes of that package. For example, LiDAR processing package of ROS2. Then there is a library of PCL involved in it. You don't have PCL, you need a specific version of PCL. So in that way, first you need to be able to build or get the binary for PCL library, then building this package is going to work. In this way, you need to have a specific building order, build the specific binary which is required in the next package. So this order is very important, and when you're building your whole project, you need to make sure which binaries have to be compiled at first, then second, then third in a specific order, so it does not gives you an error that I don't have such dependency. For example, dependency A, which is scheduled to be compiled at the 5th slot. So this way it is not going to make sense. So you have to bring an order and tell the system build this first, then this, then this. To understand different packages dependencies in order is very important. For example, I removed this package of DynamXL SDK, the binary of which we installed previously. The current ROS2 packages we have are inside of source directory Turtlebot 3, and inside of Turtlebot 3 we have multiple Turtlebot 3 related packages, and inside of source utils we have these repositories that we have cloned. Now important thing to understand is, for example, if I want to build this specific package, I just perform colcon build packages select and I can name multiple packages, but for now single package, it is going to give us an error because the dependency is missing, and the dependency is Dynamexcel SDK. Although this is available inside of the source directory, utils directory, we can still find out. And if I just perform call can build by itself, it is going to first gather all the dependencies of all the packages, and then it is going to solve those dependencies and compile everything perfectly. But for now, obviously, we need to build this first because we selected a package. So I'm going to build the package of Dynamexcel SDK first, and then the Turtlebot 3 node package. We can observe that both of these packages have been compiled successfully. The reason is that once we complete all the requirements of a package, obviously it gets compiled. So you have to provide an order if you're selectively compiling things, and select the packages using the flag of packages select with call can build. As a robotics developer, you will be doing a lot of work. There is software side, there is hardware side, but most important thing is your work should be reproducible. People should be able to add things into your work. That's the level of documentation you need. The first step of people running your project, they should be able to easily run it. And that is done through dependencies, which we try to cover as much as we can. So anyone who has confusion about dependencies, types of dependencies, specifically working with ROS2, all of those should be answered now. So if you have any question related to dependencies, you can comment, and your work should now be reproducible.